Please have a seat. On page 1 of the handout, if we could turn the front light off, please, Anthony, as you're up there. Anthony Villanueva, can you please turn the front light off? Thank you so much. Page 1 of your homework is just a review from what we covered before. I won't go there. I'll go straight to page 2. Problem number 1 on part 2 of the homework, which is something new. So we have theta is an angle in quadrant 4. Thank you very much. Thank you. Is an angle in quadrant 4, and the cosine of theta is 12 over 13. Right, and they want us to find cosecant theta, sine theta, and tan theta. So this is something brand new, and we'll walk through how to do this. So first thing I notice is that this angle is in quadrant 4. And if I just think about some logic here for the unit circle, in quadrant 4, we know that cosine is positive, and we know that sine is negative. So I got the negative sign here. If cosine is positive and sine is negative, that means cosecant, which is just 1 divided by sine, must be negative. And tangent, which is sine divided by cosine, sine, negative, divided by cosine, positive, must also be negative. Questions on the logic there? I'm on page 2, part 2, question 1. So the next piece is 12 over 13 is nowhere on the unit circle. So I'll need to do, which is why the section is called generic right triangle, I need to draw a right triangle. So let me go ahead and draw that here. My right angle, got my theta. And they've told me that cosine of theta equals 12 over 13. And I know from geometry, SOHCAHTOA, cosine is adjacent over hypotenuse. So adjacent must be 12, hypotenuse must be 13. If that logic works for you, start finding the other side using Pythagorean theorem. If you have a question on the logic, please ask. All right, so those who are good, we should just roll right through this. So a squared plus b squared equals c squared. A squared is 12, so 12 squared. B squared, we have no idea what that is. C squared, c is 13, so 13 squared. Go ahead and solve this out for b, which is this side right here. 144 plus b squared equals 169. And here we have it. Here we have it. Questions on the triangle? So now I'm in great position to answer these questions. So they want cosecant of theta. Cosecant we know is 1 divided by sine. Sine is opposite over hypotenuse, so this must be, since it's the reciprocal, hypotenuse over opposite. Hypotenuse over opposite. Here's my hypotenuse, negative sine because of the quadrant. Opposite is 5. Luis?
Can you go over again why is it negative?
Yep. Right here?
Yeah.
Okay, we're in quadrant number 4 of the unit circle. In quadrant 4 of the unit circle, cosine is positive, sine is negative. Cosecant is just 1 divided by sine, so cosecant must also be negative.
When you say cosine is
Cosine is positive in quadrant 4.
Okay.
Sine is negative, right? So therefore, cosecant, which is just 1 divided by sine, 1 divided by a negative number has to be negative also. Great. Okay, let's look at sine. Sine, I know from my SOHCAHTOA, is opposite over hypotenuse. So negative opposite 5, hypotenuse 13. And finally, tangent, SOHCAHTOA. Opposite over adjacent. All right. Let me stop before I go to number 2 and see if there are questions here on number 1. Okay, let's go to number 2. So number 2 seems a little bit trickier, but basically a very similar problem. So I'll write it, and I'll keep this frozen for those who are still copying, and then I'll unfreeze here in 1 second. Theta is in quadrant 3, in Q3, right? And cosecant so here's what we've got so far. Theta is in Q3, and the cosecant of theta is negative x over 3. And they want me to find cotangent theta. They want me to find cosine. And they want me to find sine. So, when I think about it, if I'm in quadrant 3, cosine is negative in quadrant 3 of the unit circle. Sine is negative in quadrant 3 of the unit circle. And cotangent is just cosine divided by sine, as we learned on Monday. Cotangent is just cosine divided by sine. Negative divided by negative is a positive. Questions on the logic there? Okay. So now negative x over 3 is nowhere to be found on the unit circle, so let's draw a triangle here.
Are we always going to relate back to triangles whenever we get them angles?
Right, whenever it's not on the unit circle, yeah. So cosecant is the reciprocal math term, flip is the non-math term, the reciprocal of sine. Sine is opposite over hypotenuse, so cosecant must be hypotenuse over opposite. So hypotenuse must be x, opposite must be 3, here's theta. Now many of you are wondering, perhaps, about this negative here, why that hasn't been put on the triangle. There are 2 reasons for this. 1, there can never be a negative distance. And number 2, this negative is only indicative of the quadrant we are in. Because we are in quadrant 3, cosecant has to be negative, because cosecant is 1 divided by sine. Sine is negative in quadrant 3 of the unit circle, therefore cosecant is also negative. So this negative, give me 1 second, Anthony, I'll come right there, is just indicating that we're in Q3. Anthony.
Wouldn't also the negative not be used when we do the a squared, b squared, negative?
Right, yeah. So it's definitely not going to be used on that, right? But yeah, but also not on the triangle. Absolutely. So now I need to find this third side here. So let's go ahead and do that. A squared plus b squared equals c squared. Many of you all are able to do this on your own without me. Please feel free. Here's what we've got. 1.
Could you cancel out take out of the, like, take out
Oh, okay. That trick of sort of factoring from within the square root only happens if these are multiplied. With addition and subtraction, you're not allowed to do this. Good question. Rambir?
Isn't it against the rule to have a negative underneath the radical?
Just a negative. We've got this x squared here. So x squared minus 9 will be a positive number. Why do we know that? Because x must be bigger than 3. Why does x have to be bigger than 3? Because x is the hypotenuse of the triangle. Must be bigger than the 2 legs. Question. Okay, so now we can just sort of fill in. Yep.
Another question. When relating back to the first problem,
Yep.
we started off with cosine and a theta. So then with that we use CSC and sine tangent for the three bottom equations. So how do you know to use COT depending on what it happens?
Because it says, right, determine cotangent.
Yeah, that's.
Alfredo.
Can we get the first,
Yeah, no problem.
No, I thought we were just like guessing.
He thought I was just picking them out of thin air. Luis?
Yeah, you took out, so my answer would be b equals, well, for the adjacent side would be b, square root of x minus 9.
Square root of x squared.
So you can take out the square?
No, yeah, so this was like Juan's question, right? And that will only happen if we have multiplication here. Here we have some subtractions, that will not work.
Okay.
Yeah. So here's b right here. And now we just need to fill in. So start with cosine and sine, those are the easier ones. Cosine, so toa, adjacent over hypotenuse. The adjacent side is right here. And the hypotenuse is here. Negative here because of the quadrant. Sine, opposite, over hypotenuse, opposite over hypotenuse. Negative is there because of the quadrant. And finally, cotangent. Cotangent is the reciprocal of tangent. Soka toa, tangent is opposite over adjacent, therefore cotangent must be adjacent over opposite. Adjacent is right here.
So when it's just when it's cotangent, when it has to go in front of it to switch the two?
Say that for me one more time.
Like, tangent is opposite over adjacent, when it's cotangent or like, when it's cosine, something like that, you switch to.
Not for cosine,
Yeah.
but for cotangent, cosecant, and secant. Yep. Over opposite 3. Questions on this? Okay. So I'll move to page 3, part 3. I think they're gonna need. I think this one. One. He's still there. All right. So here we go. Part 3, page 3. This is inverse trig. So I'm right here. Okay, hold on 1 second. Okay. So yeah, we are right here. Now, before I do these problems, I'll need to provide some background information. So let's assume we take the graph y equals cosine of x.